Welcome, welcome, welcome to my talk about the wonderful world of data quality tools in Python for PyGotham TV 2021. The agenda for this talk today, I'm going to do a very brief intro about myself. Then I'm going to define what we mean by data quality in this context. Then I'm going to show you a brief overview of the Python-based open source data quality tools that I found out there. I'm going to do mini demos for each of those tools, and at the end, a very quick wrap up. So first of all, my name is Sam. I am on Twitter at spbale. I'm originally from Germany, in case you hear a little bit of an accent, and I'm currently based in New York City. I've been doing data work for quite a while, so mostly working with third-party healthcare data at Flatiron Health and working on open source data infrastructure, specifically on a tool called Great Expectations, which I'm actually going to show you later on. So that explains my interest in data quality. Let's jump right into the meat of this presentation and look at what we actually mean by data quality in this particular context. So a lot of you probably have seen the 6 dimensions of data quality. They're listed out here. I've also found some variations of those different dimensions. We're not even going to talk about these today, but we're actually going to focus on what I call activities regarding data quality. So some of these activities are profiling, data documentation, data lineage, data validation and testing, version control, and cleaning. So by profiling, I mean basically exploring your data, looking at your data, and getting some basic statistics. Documentation and lineage means understanding what does your data mean, documenting that, understanding where it comes from, what kind of business logic and transformations were applied to it. Data validation and testing is fairly classic and fairly standard in the sense that we make some assertions about what we expect to be true about our data and then test the data against those assertions and see whether they pass or fail. Version control means we want to make sure we keep track of any changes that happen to our data, specifically for the purpose of, well, A, understanding what happened to the data, and B, also being able to roll back to previous versions of the data, for example, in order to reproduce any sort of historical analyses. And then finally, data cleaning is also an aspect, an activity that you do in the context of data quality, which means based on whatever issues you have found with your data, you might be removing certain values, you might be standardizing certain values, etc., etc. Cool, so I am going to show you a very brief overview of the different open source data quality tools in Python for those kinds of categories that I've just explained. So, short disclaimer, I focused on what I call single-purpose tools rather than end-to-end data processing packages. I know there's a lot of different packages out there that have some aspects of these tools integrated into them. I am mostly looking at single-purpose tools in case anyone wants to integrate any of these into their existing pipelines. It's somewhat hard to find a lot of open source Python data quality packages that are actually actively maintained. The commercial space here is growing pretty quickly. And for this purpose, I actually marked active projects that had some activity in the past 6 to 12 months with an asterisk, just so you know which ones are actually kind of still active and which ones might be a little bit older at this point. Please do let me know if I've missed anything. These are only the ones I could find by very intense Googling. Let's get started. So the first category is profiling tools. So the tools that help you explore your data and give you some basic statistics about your data. The simplest version of that, assuming we have our data in a pandas data frame, is the describe version that comes with pandas. The describe method that basically just gives you some basic statistics of all the numeric values in your data frame. So it gives you the min, max, mean, etc., etc. Pandas profiling is kind of like a much more sophisticated version of describe. It gives you a profile report. It gives you a lot more statistics. It gives you histograms, etc., etc. So we're going to show all these in the demo later on. Then if we look at the data validation space or data testing, there's a lot of data testing tools out there. They all work in slightly similar ways, which is kind of cool. So there's a tool called Bulwark, which is a data testing framework. It lets you add tests on methods that return pandas data frames. It has a lot of built-in tests, and it also allows you to write custom methods for tests. OnGuard is a precursor to Bulwark, so it's a slightly more outdated version, which does a very similar thing. I just listed it here for completeness. There's a tool called Voluptuous, which is very similar to the other tools in the sense that it allows you to specify what you expect your data to look like, specifically using a schema to validate JSON YAML. So the use case for Voluptuous that's most frequently given is, for example, getting data from an API, like a Twitter API, and making sure the data is actually conforms to that schema that we've defined. There's another library called Opulent Pandas, which is a data frame focused version of Voluptuous. So it has the same functionality, but instead of operating on a JSON blob, it operates on a pandas data frame. We also have a tool called pydqc or PyDQ, which is a very comprehensive data validation web app. So this really comes with a web app you can run and has a nice UI. I'm going to show some screenshots later that allows you to check for key indicators of your data in terms of data quality, such as completeness, freshness, latency, and validity. So PyDQ is really fairly comprehensive and has a lot of different features. So all these tools that I've just shown sort of expect you to specify what exactly your data assertions are. There's a mix of the profiling and validation tools, which basically profiles your data, and then based on what those tools see in your data, they create constraints from them that you can then use to validate another batch of data coming in, which is really, really cool. So there's a tool called TDDA, Test-Driven Data Analysis, which allows you to specify and verify some constraints on your data. It has some lightweight profiling, so it looks at your data and then creates constraints from that. pydqc is very similar. It does some data profiling, so it shows you some basic stats about the tables, and then it helps you compare things like columns between tables or compares whether two tables are identical. So that one is not in active development, so I'm not going to demo it later on. And then finally, in that space of profiling, validation, and also documentation, we have a tool called Great Expectations, which allows you to write declarative tests, but it also allows you to infer those sort of assertions from profilers and use those to validate data, to validate new batches of data. And it also outputs a report that documents the current state of your data. So Great Expectations kind of combines profiling, documentation, and validation in one. And I'm also going to demo that later on. In the space of data version control, the only tool I've found so far that's fairly advanced is DVC, data version control, which is built on top of Git. So it offers version control specifically for data and machine learning models. So it has a lot of different features, but at its core, it is version control for data in the same way as you would version control any kind of code using Git. And finally, in the data cleaning space, we have a tool called dedupe, which uses fuzzy matching to perform deduplication and entity resolution in data. So you can imagine if you have, for example, usernames, customer names, or any kind of string values in your data that actually reference the same entity, you want to merge those, and dedupe can help with that. There's other tools in the space like Data Cleaner, for example, which does some basic cleaning operations on data frames like dropping rows with missing values, coding strings as numeric values, etc., and lots more. For example, a tool called pygenitor. So now that we have looked at all of these tools and sort of talked about them in theory, let's jump over to do our mini demos of all these tools. First of all, just to introduce the running example that I have, I'm using the New York City taxi data, and I've loaded some data from January 2019 that shows for each taxi ride, how many passengers do we have per ride. So this is just a simple histogram of the number of passengers per ride in my data set. And as you can see, it goes from 1 through 6. So the majority of taxi rides have 1 passenger up through to 6 passengers. And quite obviously, there are no taxi rides documented with 0 passengers in this data set. Now, if I compare this to the February 2019 data, I all of a sudden see a spike in rides that have 0 passengers. And as much as I have doctored this data to look like this, I have to admit, I just modified it in order to show some outliers here. Anyone who's worked with data is probably familiar with the phenomenon of having data that looks pretty reasonable, and all of a sudden you have values that are completely outside of what you would usually expect, and you need to A, determine that this is happening in the data, and then B, go and figure out why. So this is the example I'm going to use for the demos. All right, let's jump over to Jupyter and show you some demos. So I have a standard Jupyter notebook here, just doing some simple imports at the beginning and then loading the data from the CSV file. So I have the January data here as the CSV and the February data. I'm just going to execute these. I'm also recreating those histograms I've just shown you in the slides, just to reassure you that it's the same data I'm using. Let's get started with the first example, which is the describe method on pandas data frames. So it's really just, I've loaded these 2 data frames, DF1, DF2, with the January and February data, and all I'm doing is call describe on it. And it gives me some basic statistics here of my numeric column. So this is the January data. As you can see, the min in the passenger count column is 1. The max is 6. That's exactly what we expect. And if we use the February data on that, we can see the min is 0 and the max is 6 here. So we can already sort of, if we eyeball it, can see there is a slight difference between the 2 data frames. Let's move on to pandas profiling, which is a fairly sophisticated version of the describe function on pandas data frames. It creates a really detailed profile report of the data. So all I'm doing here is I'm importing the profile report class, passing in this data frame, and then integrating the resulting HTML output as an iframe. So I'm just running this here. And as you can see, at the top of this report, it gives me some basic statistics about the data set, number of variables, number of observations, so the number of rows. And then if I keep scrolling down, it tells me for each column some basic statistics. And in this case, for the passenger count column, shows me I have 6 distinct values. The min is 1, the max is 6. So it's very similar to what we've just seen, but a lot more comprehensive. Now, if I do the same thing for my data frame 2, the February data, it creates like a similar report. And then if I scroll down to my passenger count column, it already tells me that, again, the min is 0 in this case and the max is 6, and I actually have a bunch of zeros here. So while these are not necessarily data quality, data validation tools as such, just having these reports and just doing some profiling on your data will often help you identify any issues with the data already if you look at them manually. Cool. So let's look at the next type of data quality tool, which is, in this case, I'm looking at data validation, data testing framework called Bulwark. So Bulwark just simply lets you add checks and assertions as decorators on methods that generate data frames. So I have a method here, load and test CSV, that returns a data frame. Obviously, this could be significantly more complex. In this case, I'm really just loading my CSV file, and I'm adding some decorators here that assert certain things on my data, such as no nans, has a shape, so 10,000 rows, 5 columns, and this is the one we're interested in, has vals within range, where I'm saying, okay, this is for this particular column, for passenger count, and this is the min and the max, and they're inclusive in this case. So testing this out with the January data. So I'm just executing this, and I don't have any errors that are thrown by this. It just returns my data frame, which means all the validations pass. So if we're testing the February data, you can already see I'm catching an exception here because this will, as we now know, throw an error because the February data is actually off and violates some of our constraints. So in this case, bulwark tells me that for the passenger count column, we're outside of the range. We have some zeros. So this is pretty cool because like you know that you can put those decorators in any method that you're or any function that you're writing that modifies your data frame or does something to your data frame, does some transformation, and you can fortify it against any unintended issues. Another version that you can to use bulwark is you can actually just execute those methods that are sort of like underlying those decorators directly. All you have to do is say import the checks class here. So check is shape, and you pass in your data frame. And in this particular case, again, you already know this one passes because the data frame is the same size, but the has vals within range function, this check will actually fail. So I'm just going to run this, and as you can see, this is what was expected. Okay, let's move on to voluptuous and opulent pandas. So it works in a fairly similar way. I am importing some stuff from voluptuous. I'm writing a method called validate data frame, where I'm specifying, in this case, I'm specifying a schema. Remember that voluptuous is supposed to operate on JSON, so I had to do a little bit of fiddling here to like actually get things into a data frame format. I'm specifying my schema. In this case, I'm saying the vendor ID column should be all integers, the passenger count column should be all integers, and is in the range between 1 and 6. So very similar to what I've done just right above that in bulwark. And then if I run this with data frame 1, recall data frame 1 should pass this. So all it does is it does exactly what my method does, which is returning this data frame without any issues. However, if I pass in data frame 2, boom, we have an exception, and it actually tells me in a pretty nice human readable way that the value must be at least 1 for dictionary value in passenger count. So this is kind of cool. All right, next up we have TDDA. TDDA actually uses a mix of profiling and data testing. So TDDA allows you to create some constraints using the discover df method on the data frame that we use as our gold standard. We just save it as JSON. We can also print those constraints. And as you can see, there's some pretty straightforward assertions or constraints in that it derives from the data. And again, like the ones that we're interested in are the min and max, the 1 and 6 on passenger count. So if we now throw the data set itself, data frame 1, at the verify data frame method, in this case, obviously this is a no-op. Everything works because we're just validating the data itself that we use to create those constraints. However, if we use this to validate data frame 2, we will see some failures. In this particular case, we see that the min constraint failed and the sign too, because we have some zeros in there. Okay, and it also gives us a summary here. So this is pretty straightforward to use, and already comes with a bunch of built-in tests, and you can also add extra tests there. Cool. The next one we're looking at is called Great Expectations. And in order to demo Great Expectations, I'm actually going to jump over to my terminal because we're using Great Expectations mostly in a CLI. So let's do that. All right, last demo of the day, I'm going to show you Great Expectations. So I've already installed the library using pip install. And I am in my data quality tools directory where I have a directory called data that contains those CSV files that I've just loaded into the notebook that I've shown you. And what I want to do with Great Expectations is I want to A, connect to the data, B, create some expectations called an expectation suite based on what we see in the January data. So I want to profile the data and then create some data assertions based on the profile results, and then want to use those expectations in order to validate my February data using what's called a checkpoint in Great Expectations. So I'm getting started by saying Great Expectations v3 API init. So v3 API is just the most recent version of it. And it asked me whether it should get started and scaffold the basic structure that has all the artifacts, all the expectations, all the configurations, etc. And I say yes, okay to proceed. And then the CLI already tells me what to do next. So the next thing I want to do is create a data source by running Great Expectations data source new. And that lets me connect to my data in this particular case because I have CSV files in a file system. I'm saying I'm processing these with pandas, and I'm saying the path is called data, right? And Great Expectations uses Jupyter Notebook in order to go through all the configuration steps. You could totally do all this in code. This is just an absence of a UI, an absence of a web app. The notebooks are sort of the most user-friendly way of doing this. This is already pre-configured, so I can execute this just top to bottom. The most important thing here to point out is I'm creating a data source called my data source, and it points at the directory called data. So I'm going to go ahead and run all. And once that's done, I now have data sources and data connectors set up, and it tells me I can close my notebook and delete it. So I'm going to do just that. I'm going to close the notebook. Okay, so the next thing I'm going to do is I'm actually going to create an expectation suite by profiling the January CSV file. So in order to do that, I'm calling Great Expectations Suite new, and it gives me all these options. Do I want to create an expectation suite just manually? Do I want it interactively, where I get feedback from every expectation that I create? Or do I want to create it fully automatically using a profiler? So in this case, I'm going for 3. And I'm going to select the first data connector. In this case, I'm going to use the January data as my gold standard to create the expectation suite. So I'm selecting 2, and I am just going to call this my suite. All right. Once again, we have a notebook opening up here. And in this particular case, it is pre-populated with everything I want. The only thing I need to do is I have this field called ignored columns. So this is a list of all the columns that I want to ignore, meaning that I don't want to create expectations for. So in this case, let's go ahead and maybe only create expectations for passenger count, which means I'm going to comment this particular column. So this one is not going to be ignored. And I'm just going to execute everything again, top to bottom. And what it did, so what the notebook here does is it creates all your expectations using the profiler, and then it actually runs validation on that data asset that you used to create the expectations and opens what's called data docs. And in this particular case, as we've seen in other examples, obviously because we used this exact data set to create the expectations, all the expectations pass when we're using it to validate itself. Okay, so now that I have my expectation suite, the last thing I want to do, I'm going to close my notebook again, is create what's called a checkpoint, which bundles an expectation suite and a data asset, and then lets me run validation. So I am going to use the checkpoint new command, my checkpoint. And I'm just giving it the name my checkpoint. Again, we have a Jupyter Notebook opening up here. And in order to configure my notebook, my checkpoint correctly, all I need to do is actually look at the sample configuration that's already provided, which basically tells me that, oh, in this case, my data asset name is actually not the one that I want. I want my data asset name to be that particular CSV file. So I can actually, if I execute everything here, I can get my available data asset names. In this case, I want to get the February data. So I am going to put the data asset name in here. I only have one expectation suite, so I picked the right suite. And that's the configuration that I want to use for my checkpoint. So all I'm doing here after this is I'm going to create a new checkpoint. I am going to review this. This is the configuration for the checkpoint, and then I'm going to add the checkpoint. So this actually saves it as a YAML file. So now we have our checkpoint configuration. The last thing I'm going to do is use the checkpoint to run validation. So just going back to my terminal, I am going to run my checkpoint. And this runs validation against the February data set and tells me that it failed, which is exactly what we expected. And if I use, if I say docs build, so if I rebuild the data quality report, the HTML files, I can already see there's another run. It tells me it failed, and it tells me exactly why it failed and what the unexpected values were. So Great Expectations is fairly comprehensive. It comes with these built-in reports, which is cool. It comes with a lot of built-in types of expectations and can do a lot of different things with it. The last couple of tools, just to switch back to my notebook, I am only going to briefly mention and show some screenshots. So we have this tool called MobyDQ, which is a really pretty well developed, pretty advanced web application that allows you to check for indicators such as completeness, freshness, latency, validity, etc. So that's one I'm not going to demo today. The next one is DVC, data version control, which really works in the same way. The syntax is very similar to Git. So you can run DVC init, which then creates a hidden DVC directory, and it allows you to add, commit, etc., kind of like like Git workflows, but doing that with your data files. And lastly, there's this tool called dedupe. I have some sample code here. I'm not going to demo it, but dedupe basically uses fuzzy matching, so and some labeling to train a model to then perform deduplication and show you what's called clusters. So this is the end of the notebook. The notebook is online on my GitHub, github.com/spbail, so you can easily jump over there and go through everything yourself. So I'm going to go back to my slides and just do a quick wrap up. All right, let's wrap up. So as you've seen, there's a lot of different data quality tools out there. Some are single purpose, others span multiple tasks. In order to determine what's the most suitable for you, really think about what are your particular needs in terms of the type of activity that you want to do in order to ensure data quality, and also which tools are actually actively maintained. What do you want to commit to using? They're open source, so you might want to contribute. And finally, the notebook with all the demos that I've just shown can be found on my GitHub page. So thank you very much for watching my PyGotham 2021 talk. I hope to see you all in person very soon. You can find me as Sam Bale at spbail on Twitter, and see you soon.